All right, my mathematicians, we are back with section 6 of chapter 3. This is going to be the last section in this chapter, and it deals with proportional and non-proportional relationships. So previously you recognized that arithmetic sequences and related them to linear functions. And now we're going to write an equation for a proportional relationship as well as write an equation for a non-proportional relationship. And that's the vocabulary there: proportional relationship and non-proportional relationship. So if the relationship between the domain and range of a relation is linear, the relationship can be described by a linear equation. If the equation is of the form y equals kx, then the relationship is proportional. We called that direct variation before. And in a proportional relationship, the graph will pass through the origin 0, 0. So direct variations are proportional relationships. So in words, a relationship is proportional if its equation is of the form y equals kx, and obviously k can't be 0, and the graph has to pass through the origin 0, 0. So for example, a table of y equals 3x might look like 0, 0, 1, 3, because 2, 6, 3, 9, 4, 12, because the y value is equal to triple or 3 times that of the x value. And you could see here that the graph goes through the origin, and then it goes through 1, 3, 2, 6. I will also point out that if you calculate the slope of this line, and let's pick 2 points that actually go through a crosshair. So let's say this one at 12 and this one at a height of 6. So those 2 points are 2, 6 and 4, 12. So if I get the slope, that's going to be 12 minus 6 over 4 minus 2, which is 6 over 2, which is 3. And notice that the slope is the same as the constant of proportionality. That's always going to be true with a proportional relationship. Okie doke. So proportional relationships are useful when analyzing real-world data. The pattern can be described using a table, a graph, and an equation. So let's look at an example of this guy's bonus pay. Marco is a personal trainer at the gym. In addition to his salary, he receives a bonus for each client he sees. So let's look at the table of data for just the bonuses he gets. So for the first client, he gets $45. For the second, he gets 90, 30, it's 135, 4, 180, 5 is 225. So if we graph this data, what can we deduce from the pattern about the relationship between the number of clients and bonus pay? Well, if we graph it, it looks like the dots go in a line. So the graph demonstrates a linear relationship between the number of clients and the bonus pay. So that means the amount that he gets per client is always constant. It's always going to be the same amount. The graph also passes through the point 0, 0. Even though it's not on the table, think about it. If he has no clients, he's going to get no bonus. So his pay from just bonuses would be 0, right? So now we know that the relationship is proportional because it goes in a line and it would pass through 0, 0. So we can write an equation to describe this relationship. The difference between the values for the number of clients C is 1. If you look up here, as the clients go up by 1, the difference in values for bonus pay is 45. That suggests that the slope, or the k value, is 45 over 1, or just 45. So the equation could be bonus equals 45 times the number of clients, or b equals 45c. Or if you wrote it with x's and y's, it'd be y equals 45x. You could check that equation by substituting values for c into the equation. So for example, if c was 1, you plug 1 into b equals 45 times 1, you get 45. That corresponds to the table. If we check 5, same thing. You plug in 5, you get 225, corresponds with the table. So let's use that equation to predict the amount of bonuses Marcos would get if he sees 8 clients. Straightforward, just plug in 8 to your equation, you would get 360. So we could predict that he would get $360 in bonus if he sees 8 clients. All right. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. All right, so let's check it out. Let's graph this data, and then what can we see from the information? So 1 goes to 75, 2 goes to 150, 3 is at 225, 4 is at 300, 5 is at 375. Looks like it goes in a line. And the setup is a professional soccer team is donating money to a local charity for each goal they score. So it also would be appropriate to think about the 0.00, because in the context of the problem, if they score 0 goals, according to their commitment, they're going to donate $0. So the points appear to go in a line, and it goes through the origin. So the relationship is proportional. Let's write an equation. So if you look, each time the table goes up by 1 in the number of goals, the amount of donations goes up by $75. So that suggests that the K value is 75 over 1, which is 75. So donations equals 75 times the number of goals. All right, use this equation to predict how much money will be donated for 12 goals. Well, that'd be pretty cool. This B right here is problem B. That'd be pretty cool if they got 12 goals in one game. So D equals 75 times 12, which is 900. So they would donate $900. Don't forget the units on the answer because it's in the context of a situation. They would get $900. They would donate $900 for scoring 12 goals. Okay. All right, guys, that's it for this video, kind of a short one. And we'll see you in the next one where we'll talk about non-proportional relationships. See you there.